So welcome to section 7.3. This one is a section that is really important. A lot of this you were introduced to in Science 9 in terms of binary compounds. The formulas you wrote were basically all binary compounds. But in this particular chapter, and you should probably have a copy of this study guide on paper, even though at some point or other you'll have to do it online and turn in the certificate. It helps as I go through it if you can just jot down a few things, even a few answers. But as I was saying, make sure that this is something you don't just do for the sake of an assignment. This is something, a skill, that obviously there's a big part of it on the provincial exam, and it's the kind of a skill that carries over into a whole lot of other chapters as we go along here. So this section and the next are very much about mastering two skills: writing formulas and naming compounds. In this section, the compounds in question will always be ionic. We're going to move on to 7.4, of course, after this, and those will not be ionic. They'll be covalent, two nonmetals. So the types of ionic compounds you need to be able to figure out how to write formulas for and name are the binary ionic compounds, basically just two, a metal and a nonmetal. Ionic compounds that have multivalent ions. You may remember from Science 9 having to write names like lead 4 chloride or iron 3 sulfate. Where you have different possibilities, more than one, multivalences, that's where that comes into play. And then finally, the other and last ionic type of compound would be those where you have polyatomic ions. Remember things like ammonium, NH4, or SO4, sulfate, acetate. All of those are combinations of elements, ions that basically then are used in compounds. So, moving right along, these are the notes. These are the basics in terms of writing formulas for simple binary ionic compounds. So binary ionic compounds are formed between two monovalent ions. In other words, these are ions that only have one charge. You look at your periodic table, you see that sodium is +1. It's always +1. You look at chlorine, it's always -1. Always, always, always. So in other words, monovalent means that you're not going to have to worry about, okay, is this one +2 today or +4 tomorrow? They're monovalent. One of them is going to be a metal, in other words, on the left side of the periodic table, or further left than the other one, and the other one is going to be a nonmetal. So typical example would be something like sodium chloride, where sodium, if you look at the periodic table, you'll notice it has 11 electrons, 2 in the first shell, 8 in the second. That leaves 1 in this third shell. It doesn't like that. It wants to satisfy this octet rule, which says, no, 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 we have to have a full outer shell. So the only way it can have a full outer shell is to give up this electron, become a sodium plus ion, Na+, and when it gives up something negative, an electron, it becomes Na+1. And of course that one electron now can go to chlorine, which has 7 valence electrons. Add one more electron, voila, 8 electrons, a full outer shell, a complete octet, and you have an ionic compound, sodium chloride, a salt. When determining the chemical formula for any ionic compound, you must make sure the total charge on the compound is 0. And of course, to do that, you have to mess around with these little things called subscripts in the formula. Step 1, identify the elements in the formula and write their symbols. Always, always, always put the element that is to the left and lower down first. That would be the more metallic ion. So let's say you're asked to predict the formula for a compound formed when chlorine and calcium react. You're not going to write ClCa, you're going to write, first of all, Ca and then Cal. Step 2, determine the combining capacity from your periodic table or chart of ions. In this case, you just look at the periodic table, you'll see that calcium is +2 and chlorine is -1. Step 3, write the formula. Since 1 is never included in the formula, you would simply write CaCl2. And of course, in this case, we can't write subscripts on paper. You would make sure that that 2 is actually lower down. It shows that you have 2 chloride ions and 1 calcium ion, and you can basically make sure that that adds up to 0. 2 Cl -1 is -2, and calcium was plus 2. 2 plus minus 2 equals 0. It's a good thing. You basically have confirmed that that's the correct formula. So that's the formula writing. Now what happens if you have to name the compounds? Here you're actually given a formula and you have to name it. Naming binary ionic compounds is easy since, again, binary means two, bi. You're only going to have two elements in a binary ionic compound. The positive ion's name comes first, that would be again the metal. The negative ion's name comes second, that would be the nonmetal. And for the second nonmetal element, you change the ending to "ide." So for example, KCl, K is the metal, Cl is the nonmetal. Change the ending of chlorine to chloride. Calcium with chlorine, you're not going to say calcium chlorine. This is binary ionic, so you just change the ending to chloride, calcium chloride. Ki would be potassium iodide, and on it goes. If it's oxygen, it's oxide. If it's nitrogen, it's nitride. If it's phosphorus, it's phosphide. I think you get the point. Allied to S, lithium sulfide. Iron with oxygen would be iron oxide. And that basically summarizes the naming of binary ionic compounds. So let's just see what Bobby knows so far. This is kind of a review of what you should know. The something or other describes the elements in a compound and their properties. What do you think? I'd suggest that what we're looking at here is a chemical formula. Wow, nice. In an ionic compound, the total ion charge is 0. That is absolutely true. It's so true, I'm going to read it again. In an ionic compound, the total ion charge, metal plus nonmetal, has to add up to 0. That's why you can confirm always, always, always that your answer is correct. You should never get less than 100% on a quiz in this section because you always know for yourself. The fundamental rule for determining the chemical formula for any ionic compound is that the total ion charge for the compound is 0. We're on a roll. And the ionic compounds are formed from the combination of positive and negative ions. These are actually charged. They're not on the periodic table. They've either lost electrons to become positive ions or they've gained electrons to become negative ions. Binary ionic compounds are made up of two elements. That's what bi means. The first element in a binary ionic compound is a metal ion from the left side of the periodic table, whereas the second element is a nonmetal from the right side. That's absolutely true. So, you'll notice this is a rather long study guide, and my apologies, but one of the essences of formula writing and naming is that it really does require practice on your part to get comfortable with it. So you may wonder what all these little white boxes are for. The white boxes are for you to actually attempt to come up with an answer first on paper before you ever put it in the little black boxes and get a score or get feedback. The reason we're doing these study guides is so you actually have that instantaneous feedback. You know whether you're on the right track from the beginning. So my suggestion to you would be to get it down on paper first, because if you try to do all of the questions in this study guide simply live, so to speak, on the computer, you may find yourself just a tad frustrated by the time you get to the end and the clock is turning, and yeah, you've got other things to do in your life, right? So anyhow, this section is writing a chemical formula or chemical name for binary ionic compounds. So notice we have a name here, strontium sulfide, and you're having to give a formula. Here we have a formula and you're asked to give a name. So in the case of 7A, strontium sulfide, the first thing you're going to do, because you're given the name, is you're going to write the symbol for strontium. Then you're going to write the symbol for sulfur. And based on their combining capacity, sulfur's -2, etc., etc., all of this you can get off the periodic table or your table of ions. You're going to come up with a formula SRS. Right. And again, you know what, if you have questions as to why that's the case, you'll notice that the charge on strontium and sulfur is going to add up to 0, and that's what this is about. This is a metal ion, this is a non-metal ion, positive 2 plus negative 2, they basically cancel each other and add up to 0. So in this case, we're given a formula, calcium and chlorine. So you simply write calcium, chlorine, and then because it's binary, just change the ending on the nonmetal ion to "ide," and you should get calcium chloride. In C, lithium bromide. By the way, feel free to pause the tape at any point and just try a few of these if I'm spoiling your joy here by doing these for you. I'm not going to do them all, but I just want to give you a few examples. Lithium bromide, name. You were supposed to write the formula. You know the symbol for lithium is capital Li, and then bromine is capital Br. Look at their charges, combining capacities. Bromine's -1, lithium's +1. They already balance, so it's just LiBr. How about D? Potassium is +1. Oxygen is -2. That's why you've had 2 potassiums in that formula. But you're already given the formula in this case, so all you have to do is recognize that this is in fact potassium combined with oxygen as potassium oxide. Easy. So I'd encourage you to, at some point, if you get tired, stop the tape, try a few of these. You might even want to enter your answers on the study guide and just find out how you're doing. By the way, now and again you're going to actually encounter a computer glitch or some little typo where I put a space in or something and the computer says, again, don't panic. Just when the score comes up and you're close, I'm happy with it as long as you know how you're doing with these. So moving right along, we're now looking at the examples and notes on ionic compounds with multivalent. Again, they're still ionic, they're still a metal with a non-metal, they're still charged species, so to speak, that are combining, but now you have to worry about whether they're in fact elements that have more than one combining capacity. For instance, here we go. Some metal ions, think of iron, think of lead, a whole lot of them on your periodic table in the middle in the transition metals have more than one combining capacity. We say they're multivalent. For example, iron can be iron 2 or iron 3. Copper can be copper 1 or copper 2. Notice that when you put these in a name, you're not actually going to use Arabic symbols, you're going to use Roman numerals. More to be said about that momentarily. See periodic table. So I'll show you that in the periodic table here in a second. But writing formulas for multivalent compounds is easy since the combining capacity of the metal ion is given to you in the name of the compound. If I say iron 3 chloride, you already know what the charge or combining capacity is of the iron. It would be the iron 3 rather than the iron 2. The reason why you have to specify it is you need to be able to say which one it is. So once you know the combining capacity of the metal, then you can simply figure out the combining capacity of the nonmetal simply by deduction, since you know the charges must add up to 0. For example, the name iron 2 chloride tells you that the charge on iron is 2+. That's what the 2 tells you in brackets. And since your periodic table tells you that chlorine has a combining capacity of -1, you know you need 2 chlorine ions to make up the neutral compound, and you end up with the formula FeCl2. So you should try one. What is the formula for nickel 3 bromide? I'm thinking I actually answer this at some point, but to name a compound with multivalent ions, you simply need to reverse the process. The key is to identify the metal ion as multivalent. For example, give the name for tin fluoride. Okay, for those of you that are frustrated because I never gave you the actual formula for nickel 3 bromide, the formula for nickel 3 bromide, they tell you that nickel is +3, bromine is -1. You now know that you're going to need 3 bromide ions to balance the +3 charge on nickel. So you will get as a formula NiBr3. NiBr3. So now we've gone the other way. Now we're given a formula and we have to name the compound. So for example, give the name for SNF2. Fluorine, you already know, is going to be fluoride. Tin, if you look on your periodic table, exists in more than one combining capacity. Fluorine, like I said, is -1. Formula shows you that you have 2 of these ions. Total charge on fluorine is therefore -2. Since the total charge on the compound must add up to 0, you know that the version of tin that you have on your periodic table has to be tin 2+. And again, in a name, that would be shown as the tin in a Roman numeral. The name of this multivalent compound is therefore tin, in brackets, Roman numeral 2, fluoride. So, all of that is going to take practice, and that's again what the purpose of this study guide is. This flowchart, by the way, was something you were given in Science 9, just to help you determine which type of naming to use when you are given a formula. If you find it useful, do see me and I can give you another one. The hope is eventually all of this becomes built into your brain anyway. So they give you a formula, ask yourself if it starts with a metal, is the metal able to form more than one ion? Then you basically have what's called a multivalent ion. If it's no, then the name of the metal ion is the same as the element name, and the negative ion has more than one element. No, then you just change the ending to "-ide." And that's pretty much as far as we've got. So this is your periodic table. Periodic table from your data booklet. And the only reason I'm showing you it here is to emphasize that you really have to have this open in front of you when you go through any of this chemistry material, because so much of it is dependent on you actually searching out your answers from the periodic table. So we've just been looking at multivalent ions. By multivalent, we just are pointing out the fact that these ion charges, there's more than one. Everything other than these ones with this slightly violet color are monovalent. They don't have more than one charge. All of the alkali metals have a charge of +1, and of course you should be able to explain why that's true in terms of their valence electrons. And if you can't do that, I would be so delighted to talk to you and we could work that out. Same thing with the alkali earth metals. They all have an ion charge of 2+, and again, can you explain why they all have a charge of 2+ in terms of the octet rule and valence electrons? On the other side of the periodic table, all of these have no charge. They aren't likely to combine with anything, the noble gases, and they are very stable, right? And again, halogens are all -1, -2. Everything in the middle, the transition metals, be careful. If you are asked to write a formula, name a compound, make sure you're looking at your periodic table, and once you recognize, oh my gosh, it's manganese. Is this going to be manganese 2, manganese 3, manganese 4? You're going to have to actually determine that by looking at the non-metal. Okay, hopefully we can speed up a little bit here, because if you really want to get this done, listening to me talk isn't the best way of doing it. You actually want to get in there and try some of these yourself. So, when we're looking at number 8, we're looking at chemical names and formulas now with potentially multivalent elements. And by multivalent, you know what those are. So what I would encourage you to do, just based on the previous notes, is to attempt at least the first 4 on your own, and I'll then go over them with you just to make sure you're on the right track. And again, you're going to need your periodic table to do that. So feel free to stop the tape at this point and yeah, try them. So molybdenum 3-sulfide. They give you the Roman numeral that is your ion charge. Sulfur's ion charge is -2. Make those equal. You're going to need 2 molybdenums. 2 times 3 is +6. 3 times -2 is -6. And of course, again, the subscript issue in this program is I can't draw subscripts. Make sure that on paper, if you ever do these, you actually draw them as subscripts. PbCl2, you know what Pb is, it's lead. You know what chlorine is, it's chloride ion. You've got 2 of them. And each chloride ion is -1. 2 times -1 is -2. That tells you that this has to be lead 2 chloride. So put it in brackets, write it as a Roman numeral, and now you have the name. In the third example, you're given the name, and you're asked to write the formula. Bromine is -1. Rhodium is +4. Guess how many bromines you're going to need? 4. Rhodium 4 bromide. In example or question D, oxygen is -2, and you've got 2 coppers, so each copper must be +1, because 2 times +1 is +2, which balances the ion charge of oxygen of -2, copper to oxide. So, finally, sweet notes. The last group of ionic compounds are polyatomic. Poly means many. Here we go. A polyatomic ion is an ion composed of more than one type of atom joined by covalent bonds. Because polyatomic ions carry an electric charge, they cannot exist on their own. That's right, just got a text message. An example of a polyatomic ion is carbonate, CO3, with a charge of 2-. You will have a copy of the polyatomic ions in your data booklet. You may not have the chapter checklist yet, but you should have access to these polyatomic ions. You don't memorize them, you're always given them on tests, so don't panic. Poly simply means many. Per, hypo, ate, and ite are prefixes and suffixes that help indicate the number of oxygen atoms present in some polyatomic ions. For the steps in naming compounds and writing formulas that contain polyatomic ions, see the next page. How exciting. So let's do a few examples of writing formulas of binary ionic compounds. I guess in this case we wouldn't say binary because we're going to have more than 2 elements in these compounds. But these are compounds with polyatomic ions. So if you desire, are welcome to a copy of this actual page. And yeah, it also includes the notes from the previous page. So if you haven't written them down in your own copy of the study guide, feel free to talk to me and I'll get you a copy. So we're looking at a name, manganese 3 chlorate. Immediately you notice that chlorate isn't anything you're going to find on the periodic table. So that immediately tells you that it has to be on your chart of polyatomic ions. So you look at the chart, identify each ion and its charge. Manganese, they tell you in the formula, is 3+. Chlorate, you find on your chart of polyatomic ions, is -1. So now determine the total charges needed to balance positive with negative. So if manganese is 3+ and chlorate is -1, you're going to need -1 plus -1 plus -1. In other words, 3 times -1 to get -3. So note the ratio of positive and negative ions. For every 1 manganese ion, manganese 3+ ion, you're going to need 3 chlorate -1 ions. Use brackets around the ions to correctly show the ratio. Most of us don't actually do this step because you're just going to have to get rid of those brackets in the end anyway. So use subscripts and brackets to write the formula. Omit the brackets if only 1 ion is needed. All that means is that manganese, there is only 1 ion here. No point in having it in brackets. Whereas chlorate, that one, you have 3 ions, so you're going to have to put chlorate in brackets and have a little subscript 3 outside the brackets to say that you've got 3 of these polyatomic ions. So 3 times -1 is -3, which balances the +3 for manganese. So let's do another example. Ammonium sulfate. Ammonium is kind of cool because it's the only positive polyatomic ion. If you look on your chart, you're going to notice that ammonium is NH4 with a charge of +1. Sulfate, on the other hand, SO4. And by the way, you can never mess with these polyatomic ions. Don't ever change like the 4 to a 2, or in chlorate change the 3 to a 2. You have to go with whatever the formula for a polyatomic ion is, and then just adjust the entire charge of that polyatomic ion by using brackets and a number outside the brackets. It's almost like the distributive principle in math. So in this case, we're going to determine the total charges needed to balance positive with negative. Ammonium, it looks like our only option is to say, okay, well, sulfate is -2. How many ammoniums am I going to need to balance that -2? I'm going to need 2 ammoniums because each one is +1. So 2 ammonium ions for every 1 sulfate ion. Then you got the brackets step. In this case, you're going to maybe keep the brackets or maybe not. You're going to need 2 ammoniums, but you only need 1 sulfate. So you end up dropping that bracket and you have ammonium sulfate. So again, on the back of the sheet I just mentioned, you are welcome to pick up a copy and try these on your own. Again, all I'm doing here is saying, you know what, you really want to master this stuff. Do a few, if you keep getting them correct, there's no point in doing something you already know how to do. Put it away, move on to something better. So the answers are actually provided for both of these, and it's just a great way to make sure you've actually mastered the information so far. There is one last section, and we'll move on to that. Write either the chemical formula or chemical name for these ionic compounds with polyatomic ions. So now we're putting everything together just to see if you can put it together yourself. Again, you will need your table of polyatomic ions. Took the ones from your data booklet here, and it's a lot easier, of course, if you use your own data booklet. These are all polyatomic ions. I mentioned ammonium's the only positive one. Acetate's kind of a funky one, but get used to hearing some of these because, again, you want to make sure you recognize them as polyatomic ions. Permanganate, phosphate, phosphite. Right. So, if you have to write the formula for sodium acetate, you can check your sheet for what acetate looks like, but it's basically CH3COO with a charge of -1. If you take organic chemistry, you'll see why it's written the way it is. It's referring to kind of a structural arrangement of that molecule. But all we have to know is that, sodium, Na, and then the acetate, and then make sure that they actually add up to 0. So what you should end up with is something like that. Acetate was -1, sodium was +1. They're going to add up to 0. Again, I would encourage you to maybe pause the tape at this point and maybe do the first 4, see if you're on the right track, and then come back and I'll give you the answers. So in this case, we're given the formula. You're asked to give us the name. You know what lead is. You know what CrO4 is because you have a chart of polyatomic ions. Chromate. Lead to chromate. And again, chromate is -2, so you know that the lead, again, is a transition metal. It's polyatomic, so you have to use the Roman numerals. By the way, if you use the Roman numerals where you don't need to use Roman numerals, that would be considered wrong. So make sure you're only using these Roman numerals for transition metals. Barium acetate. Barium is Ba. You already know what acetate is. Barium is +2, so now you're going to need 2 acetates, and of course the 2 will be a subscript, saying you've got 2 acetate polyatomic ions. D is called calcium sulfate. Again, if you have any problem with some of these, make sure you talk to me about it. If I'm not mistaken, this last one is the last page. A couple of interesting things we're doing here. We're trying to jam in 2 things. We're asking you to recognize the name here as binary, multivalent, or polyatomic. If you can do that, then you probably know the rules you need to follow to actually give the formula or the name. In this case, you're given a name and asked to write the formula. Formula should be KCH3COO, and we are dealing with acetate, which is a polyatomic ion. So you would click on that. PbF2, you know it's lead, you know it's fluorine. Change the ending on the binary ionic compound to "ide," and now you have to figure out whether it's lead 2 or lead 4. Because the total charge on the fluorine is -2, you know that the lead has to be +2. And you recognize that there's just 2 elements in that molecule, therefore binary. Calcium acetate. Calcium acetate is polyatomic. Lithium oxide, looks to me like that's binary again. And the actual name, simply lithium oxide. So I think you should be fine with the rest of them. Hopefully there's not too many computer glitches in there. Like I've said, with all of these, get close to 100%, and I'm very likely to bless you with 100%. Something like this study guide, you really don't want to have to do more than once. So thank you for coming. Bobby's not too happy with his score. Bobby's probably going to exit.